This is our first go at a solid of revolution. First of all, a solid of revolution, you can have two calculations. You can have volume, or you can have surface area once you start going 3D. Today, we're doing volume. We're doing volume in this section, and we're going to do volume in the next section. Okay? Now, before we get started, the area of this graph, see this line? The area of that graph, you see how it's going to the x-axis? Okay? If I draw that rectangle, to me that means the area would be from A to B, f of x dx. Very important. Okay? Now, I think in trig I mentioned Archimedes' tombstone. He felt his greatest accomplishment was the ratio of the volumes of the cylinder, cone, and sphere had a ratio of 1 to 2 to 3. In other words, 3 cones fit inside one cylinder with the same height, same radius, and 2 spheres fit in the same cylinder with the same radius and diameter. What that's to do with it is taking a two-dimensional object and rotating it. This one rotates through the center, and you spin it, and it becomes a cylinder, a sphere, and a cone. If you have a hard time seeing that, you might want to think about it for a few more seconds before I go on. If you spin on a stick a cylinder, the image traced out would be a three-dimensional, or spin a rectangle, the image traced out would be a three-dimensional cylinder. If you take that cylinder off and put a triangle on top to bottom in the middle, spin it, you could actually see the remnants of a cone. Okay? Same with a sphere. You spin it really fast, you can see it tracing out. A circle would trace out a sphere. These two-dimensional, if I take this object, this rectangle, and I spin it, it creates a very squatty looking cylinder. Okay? Very squatty. Very, very squatty. Okay? I'm not very good at art, but that's why I have these pictures. You see how this rectangle, if I spin it, gives you the cylinder in yellow. Okay? What is the volume of a cylinder? The volume of a cylinder. Pi r squared h. Okay? So, pi r squared h is the volume of a cylinder. If I want to add up a bunch of cylinders, I could take the sum of all those cylinders, and I could add them up. If you added up all the cylinders, you see how this might approximate the entire region if you took that entire graph and spun it, here's the key, around the x-axis. You could add them up. We have to adjust our integral, because our integral means you add up all those partitions, all those cylinders now, and we have to use this equation, pi r squared h. Well, pi is a number, correct? So pi, I said I do this a lot, I would take it outside my integral. The question is, what's this distance right here represent on my cylinder? Does that represent the height, or does that represent the radius? That little distance, that little dx right there. Yeah, it represents the height. So dx, the width of it, represents the height of the cylinder. So what does the function represent in my cylinder? Yeah, it represents the radius. So in order to find the volume of a solid rotated around the x-axis, it is going to be f of x squared dx from A to B. One thing very important I want to say is that my rectangle is perpendicular to my axis of rotation. When your rectangle is parallel to your axis of rotation, that means you set the integral up differently. I'm using a vertical rectangle here. That makes it dx. Okay? So the vertical rectangle goes dx. The fact that my rectangle goes perpendicular to the axis of rotation, that gives me the pi r squared. Okay? The a and the b are x values. This is where things get a tad bit confusing. This I can equate to finding the integral from the graph to the axis. You see how you're finding the volume of the solid from the graph to the axis? You should know what's coming down next in line after we get through today. Okay? Probably after we get through tomorrow, actually. I won't get through it all today. So, with that said, here's a little rule that you can go by. I wasn't here last time, but that summation of the partitions with the limit going to 0 is represented in that integral sign. That means all of this, okay? The pi, I always put out in front. If I'm doing a calculation on the calculator, I'll do that function integrate. I'll put parentheses. You know, I'll put my y1 squared, comma x, comma a, comma b. Whatever I get, I'll tack a pi onto my answer. I won't put pi into my calculations because it won't come out as a fractional answer. Pi is an irrational number. So when you see me do a few of these problems, you're going to see I won't be putting pi into the calculator because I know I got to multiply it by my answer. Okay? I just think about it. How are we doing so far? Hanging in there all right? Okay. It should be all right today. Thursday will be a lot of fun. Wednesday will be okay. Friday's up to you. All right? All right. Here we go. I'm going to ask a quick question. The axis of rotation is the y-axis. My rectangle goes to the y-axis. So how would I set up my integral to find the volume of this graph rotated around the y-axis? Well, I'd use g of y. C is my lower bound. D is my upper bound. They are y values, aren't they? Those are y values. And how do I set up my integral? dy. Two more things I have to change. I have to square it. And I have to put a pi. If you think about it, it is like finding the volume of a cylinder. And the integral sign just adding up all those cylinders together. Okay? Pi r squared h. dy, g of y squared, and then pi goes outside your integral because it's circular in nature. You can find the volume of a lot of interesting shapes. Okay? But remember, on the left side of the y-axis is a negative, on the right side is a positive. Okay? So that's what this is saying right down here, another little box. Check. I think we're good. Ready to do a little applications, ready to get our calculators going. What do you think? All right, let's do this. Oops, went backwards. Nope, we want to go forwards. Here's a guideline in your book that you can follow if you like. That would be if you were like really lost. Okay, so these are two problems, 1 through 4. Set up integrals that can be used to find the volume of a solid obtained by revolving the shaded region about the indicated axis. Your drawings from now on have to include which axis you're rotating it around. Okay? You need a sketch. Me, I add one other thing to this. I add my rectangle. To let me know I'm going horizontally with my rectangle. To let me know I'm integrating to the y-axis, so I know it's a dy integral. That tells me it's dy. We only know one way right now. We must be perpendicular to the axis. Okay? We don't know the other way yet. There is another way. That'll happen Thursday or next week. Depends how Thursday goes. So perpendicular to the axis. All right? We're in good shape. Here's the y-axis, and here's my rectangle. So my y bounds are going to be what? Yeah. 0 to 2. That's C and D. I need a pi in there. Yeah. Y squared minus 4, and that you have to have x equals. So you have y squared minus 4 squared dy. Okay? So you can see a little bit, the reason I spent a little bit of time on 5, 7 was you're going to have to get these graphs entered correctly, and then you're going to have to set up your integrals correctly and calculate them correctly. But don't put the pi in your calculations, add that to the end of your answer. That way you get answers that match the back of the book. We are not calculating this yet because it just said set it up. So on this one, I reserve the right to do this one tomorrow. Okay? Does anybody see a potential problem with this one? Well, sort of. But this, my rectangle, it doesn't go all the way to the axis, does it? I think we're just going to worry about going to the axis right now.
I like that.
What number was that one?
That was number 2.
Can't we just do the whole thing and then subtract the...
You could. Yeah, you can go from, what number is this? Negative 1 to 1? Negative 1 to 1 of pi times negative 2x squared plus 2 squared dx minus negative 1 to 1 pi negative x squared plus 1 squared dx. The problem is those have the same bounds, don't they? So if they have the same bounds, how can you write that as one integral? Right, you have pi, negative 1 to 1. It's going to be a complicated expression. Oh, what the heck. Negative 2x squared plus 2, all squared minus negative x squared plus 1, all squared dx.
So is the only difference that you have to remember to put pi in front of it?
Pi and squaring it are the two main differences. Okay? All right. Ready? All right. Sketch the region bounded by the graphs and find the volume. So you have 3 graphs and your axis of rotation. So this tells you how you have to set the integral up. Today, you don't have a choice. After today, after tomorrow, you'll have a choice. Like area, you had a choice. Volume, you don't have a choice right now. You have to go around the x-axis. And it is actually kind of surprising to me that the hardest part is some people actually getting the graph. If you can get the graph, you should be able to get the integral. So square root of x. X equals 4 is a vertical line. This is a, start and a flare. And this is the x-axis. Okay? So that's the region that I'm rotating around the x-axis. This point right here is obviously going to be 4, 2. This point right here, 4, 0. This point right here, 0, 0. And I'm going to put that on my calculator. Y equals clear, clear, square root of x, square root of x. I cannot put in the vertical line of 4, but I can change my window to go from 0 to 4. And y minimum, maximum, I don't really care. So there we go. So I'm going to rotate that around. So I have it. I have to set my integral up. Again, you'll see me do this on when I'm correcting papers. You should not miss this being a dx integral because it's a vertical rectangle. That's vertical, dx. We're talking volume, so you're going to have a pi, and you're going to have something squared. Why aren't you subtracting in this case? Yeah, because when y equals 0, that involves the x-axis. There's no gap. Everything goes straight down. And the equation I'm putting in there is square root of x from 0 to 4. Now, calculating it. You could do this one manually, couldn't you?
No, I wouldn't.
You wouldn't?
I wouldn't either.
Well, I'll give it a shot. Math 9. Bars, y bars, squared, comma x, comma 0, comma 4. I want to fractionalize that answer. So it's 8 pi. Anybody else get 8 pi? Okay. Anyway, I say we're in good shape. Yes?
So it's like my weird little thing, do I just put the squared on the inside of parentheses after the squared x or what?
Outside the parentheses.
I can't get it.
Insert parentheses. Okay. Anything else? All right. Let's try another one. These are fun. Y equals 1 over x. Y equals 1, y equals 3, x equals 0, the y-axis. FYI, based on past experience, x equals 0 means the y-axis. Y equals 3 and y equals 1 means vertical lines, or horizontal lines, sorry. Horizontal. Y-axis means what kind of integral? Right, it's going to rotate this way. We have no choice right now except to go with the dy integral. Regardless what the equation is, we have to go with the dy integral because we want to be perpendicular to the axis of rotation. Yep, they would be. 1 over x is going to be the reciprocal function, of course. 1 divided by x. You know what? I'll do this. I'll put 1 over x. I'll put 1, and I'll put 3. Yeah, I'll do that. Let's see. Let's go negative 5 to 5. Negative 5 to 5. Graph. Like that. And there's nothing there yet, and there's the region. Okay? So the region we're looking at is one intersected by all 4. That's a lot better picture than what I had. So I want this region right here rotated around the y-axis. So yeah, the 1 and 3 would be your bounds of integration. 3 to 1. 3 to 1. All right, we're ready. Set this up. How's everybody in the back, all right? So for these problems, just like on Friday, you're going to have a graph, you're going to have an integral, and you're going to have a solution. The graph must include your axis rotation, the graphs, the integral, 1 to 3, pi, 1 over x, squared, dx. We doing all right? All right. And this is the nice thing about doing it like this. Second, enter, from 1 to 3. Now, I've heard rumors that in Calc 2, they're starting to use graphical integration all the time. In Calc 2 also do that. But we're in Calc 1. We'll learn a little bit. Yep.
Manual it.
2 pi over 3. Yep.
So we don't have to worry about changing it to y if we go to the y-axis?
That's the back.
Oh, the integral, you're right. My fault.
Yeah. I can't.
Oh, wait a minute. I do need to change it.
What was the first one?
I know, but I just botched that problem up. I wasn't even paying attention to the y-axis. I got half and half. Wait a minute. It turns out the same. X equals 1 over y. Well, I should have addressed it, nevertheless. I should have addressed it. Reciprocal function. 2 pi over 3. All right. Now I got the right integral with the right graph. And Ben, you can be rest assured that's correct.
And Betsy.
Betsy doesn't listen to me. She turns down the volume. We've already established that. All right. X-axis.
I wonder if that was going on if I just watched this. I'd be like,
Anyway, x equals y cubed. X squared plus y equals 0. The x-axis. So, first of all, to graph it out, we can do either parametric or we can do y equals.
What's the parametric? I want to know.
Wake up and say not parametric.
I wasn't asleep. I was just resting up.
Now,
Okay, sleepy.
since I have an x-axis, which way am I going to rotate the graph? So am I going to do a dx or dy integral? Dx. So I might as well do everything in terms of y equals since I'm going to do a dx integral anyway. There'll be one later on. So, on this one, y equals the cube root of x. On this one, y equals negative x squared. And the x-axis, well, that's the rotation. So I think we're about ready. Cube root of x, negative x squared. Y equals clear, clear, clear. Cube root. That's number 4. Cube root of x. You could do x to the 1/3, but I didn't. Negative x squared. I'm not sure exactly what's going to happen, so I'll just... Right. That looks all right to me so far.
Ooh. Oh.
So it looks like the region that is right there. That's what I'm guessing. The problem is, when we set this integral up, we're not going all the way to the x-axis. So we're going to subtract. Whenever you have this situation, you have to subtract the greater volume. You subtract from that the lesser volume.
So this isn't going to be weighing a whole lot from
Nah, let's do it. See if Betsy turns up the volume for this one. Exactly. So, anyway, yeah, so if we do it, it'd be, which one would have the greater volume? The one with the red cylinder or the blue cylinder?
Red.
And which graph is that? I think that's the x cubed. It looks like I'm going from negative 1 to 0, pi times the cube root of x squared minus negative x squared squared dx. Need brackets. But you have to understand you're subtracting the volumes. So I think you do the bigger volume subtracted from the smaller volume. Not like area. Yeah. Okay. Let's see if it works. Second, quit. Second, integrate. Which one do I have as y1? The cube?
Yeah.
You're going to have to check. No way.
I know.
Okay, you do.
Minus bars. Y bars function by 2 squared x, quiet please, -1 to 0. -1, comma, 0, parentheses, math, frac, and the hope is it comes out positive.
Yes.
The answer always has to be positive.
Like fractions.
0.4 is what is a fraction?
Or 10. Oh.
2 pi over 5. Okay? Sure. Because you want to have a positive volume.
Why does mine not go to
It didn't. I changed it.
Oh, okay.
I changed it to 0.4.
I'm so out of it.
It is. Because the volume, if you square a negative number, is going to come out positive. If you square a... Now, it changes with lines, but we aren't there yet. Right now, the axis is our middle of our cylinders. Yes, Taylor?
I know which line is bigger.
Well, which line's longer, the red or the blue? Which radius is bigger, the red or the blue?
Oh, it's just the little area.
Right. It's just for the little area between those two. Okay? Time is it? I think I'm going to let you get started. And I want you to go through...
13.
No, some of you didn't have very good days. You need to buck up. So we'll go through 19. We won't do any trig till tomorrow. Okay? It's 321. So page 321, 1 through 19 odd. So tomorrow and Thursday, Wednesday we'll do part 2 of this. Thursday we'll do part 3 of this. Friday is your quiz over 6.1. I'm telling you, some of you really need to take this quiz seriously because it's 25 points. 20 to 25 points. I haven't decided which yet. So that's the plan.